So for today's assignment, we essentially have what is called Exercise 5, and it's topography, site, and topo, essentially. So, I've been hinting at this the entire time, but essentially we're going to start making an observation tower from our abstract models, from our stairs, and essentially we're going to start putting these all together. But we want to do one thing at a time. So we're going to start with the foundation because in architecture, we don't start at the top of the architecture, we start at the bottom, the foundation. And of course actually means the earth, right? We definitely study the earth, right? Site analysis, we study the wind patterns, all these different things. But arguably one of the largest and most contingent ones on our architecture is the ground soil, right? In fact, we even do a lot of testing on the soil to make sure that it will even hold up the architecture itself. In fact, this is how we discovered Natural Bridge Caverns, because we were building I-35 all the way from Austin to San Antonio, and they go, hey, there's a cave underneath, because they were doing all those drills, right? So again, you learn a lot about the earth when you're drilling some cores. However, for this next exercise, we're going to develop the skills of digital design and fabrication in the context of architecture. So we're going to build it too. We're going to laser cut it and hopefully start talking about the laser cutter tomorrow. I do want to introduce it to basically both groups so they can start getting used to some laser cuts. So we're definitely going to do that for our topography. And no, we're not going to make this complex of a model, but it is very similar in method. I usually scare students when I show them because this is actually what we did at first, and this is actually one of the students' works. It also took them way too long to make this. It was actually very costly too, but again, very nice actually. Anyway, step one, using the command contour, we can be useful and we can already have a sense of a surface model. However, typically in Studio, we are given the site and sometimes even the topography from a land surveyor. After we have traced and created a topo model, we can now prepare the model to be sliced and printed via laser cutter. Now that's pretty much step one. That's all we're going to really cover today is making a topography surface, showing you how to get it onto the laser cutter, and essentially going from there. Obviously in part two, we're going to show you how we take the stairs, the abstract model, and the site and put them all together. That's essentially next time. So if you're kind of anticipating that, you still have time. You still can work on your abstract model. You can still work on your stairs. And let's face it, you can use this weekend, if you must, to knock out the topography, which is arguably the easiest part anyway. Plus, you saw a little bit of it with Team A. So, obviously really the only one for this one, and we'll talk about some of the deliverables once we get there, but we're essentially going to make a 3D print for this as well. And again, that's in part 3. So again, this is only Team B, right, not Team A. It will be judged on its craft and accuracy, and of course the composition of the communication of all those elements. So we're going to start doing an axon diagram and things like that. Basic schedule, you guys knew yesterday and Monday was basically working class, and of course the stairs are due today, and of course starting to talk about topography and laser cutting. As you can imagine, next week, no class on Monday, and we'll continue to part 2 on Wednesday for you guys. So anyway, just sticking to it and getting into the schedule. Almost forgot the instruction. So the first thing that we actually need to do is pick a site, and this site, really the only thing for my Team B, we just need a 48 feet by 48 feet square, right? And that can be really any square in San Antonio. However, please don't spend a week picking a spot, right? I can't tell you how many times students, they kind of like actually get stuck on picking a spot rather than honestly just picking anywhere. And you can actually even pick the same spot if you essentially want to follow along with me today. Totally fine. I'm not grading for the spot that you picked, but it is kind of interesting. So we do need a 48 by 48, and I actually put this HTML in there as well, the website. The first task will basically be trace and find our contours. The question for selection is, where should your observation tower go? And of course the example today is from San Pedro Springs Park. Of course, right across the street, and we are, where are we? Here, in a large tall building. Usually I go to this corner because, I don't know, there's kind of a sidewalk to nothing, and I always kind of imagine to myself, like, hey, what if we completed those stairs, if you will, and turned it into an observation tower instead of the stairs that into nowhere and you suddenly just fall down this, this dirt path. So I've always been like, hey, it'd be really cool to put an observation tower there. So I'm going to do it again. In our case, I do need a measurement of some kind, right? Now, I could take some screenshots to actually get a better idea of what's going on, and to be fair, we could actually go across the street and take pictures ourselves and a measurement ourselves, which is always the best way, guys. Don't get me wrong, I love Google Earth, but it's only so accurate, right? Let's face it, if you can go there and you can just measure it, that's always going to be more accurate and definitely sought out, especially in a studio. And you really don't do this until about D2. If you're in my D1 or Kernodle's D1, we definitely have a site, right? But not every studio professor in Design 1 necessarily has a lot of site detail. Anyway, so let's get a 48 by 48 foot measurement. In my case, I'll hit the measuring tool. I think by default it's in meters. Oh, but mine has switched to feet, so we're good for today. In my case, I want to make sure that I basically just get a 48-foot line, right? And I can't really hold shift here, by the way, so I can't make it perfectly straight, but we'll fake it till we make it for today. And there's that elevation, and I want to hit done. That way I can essentially keep that measurement here. I actually think I have to save it to the project. It's kind of weird. 48-foot measure. But you do have to save it, otherwise if you just cancel and just exit before saving, I think it actually goes away, so be careful with that. As you can see, I have a lot of measurements now because of it. But in our case, I do want to zoom out a little bit because I do want to essentially match it up with that map that you may have saw when I was talking to Team A. But we do need to basically align it to that topography. And I do want you to pick something visually interesting, right? I mean, don't just select something that only has like 1 or 2 lines. It's going to be a pretty boring model, right? I mean, it's only going to be like 3 layers. So choose something that is somewhat challenging. Right, so obviously my area right here, we got San Antonio College, we have what is the street and the street, but we have all the topography lines, of course, that are showing those things. So we're going to trace something at least close to there. And as you see, we still have some decisions we can make. But for today, I'm going to take a screenshot. I'm going to do a little bit more than necessary because, again, I can always take away. I can't necessarily add as easy as I can take away. So I do want to get enough information, and that's looking pretty good. The second one, this is the one I don't have to have be so big. In fact, usually on Google Earth, we want to be as close as possible because it usually offers the most detail. Another interesting feature that I forgot to show Team A is you can actually go back in time, which is really interesting. So if you say show historical imagery, what's really nice about that is sometimes there is a better aerial shot. No offense to Google Loon, but I mean, I don't know what it is, but in 2023 we had grass, and I don't know about you, but in studios sometimes we want to show our site in the best light, right? So there's nothing wrong with actually going back in time a little bit and going, ooh, this might be the better shot. It's still the same spot, but now I can actually show it or even know what to do to Photoshop it. For instance, this happens a lot in studio that our site has changed or undergone a lot of different changes, and it's kind of nice to even show a diagram of, hey, this is what it looked like in 2008, this is what it looked like in 2012, and this is what we're proposing for 2027, right? That way there is this logical sense, and again, information and knowledge is power. So, I don't know, I'm feeling green today. Oh, it's got some cars in there too. All right, I'll take it. So I'm going to actually use this for my screenshot today. However, I always do like to see how far back we can go, and I already know this one. We can go all the way back to 1995 when I was 5 years old. I don't know, I just like to look at it. It's also, what do you call it? Black and white. So, man, it's just so crazy to see how much, I mean, look, that stair was not always there. So it makes me wonder, who's the asshole who just built a stair to nowhere, right? And we could pin it down at least by the year. Maybe we won't find the guy, but you know, it is kind of interesting to go to 1995 and go, wow, that's what SAC looked like. It used to be surrounded by parking lots. Yeah, it really did. And I could even start to do a diagram of, you know, the parking lot changes alone at San Antonio College. So again, excellent resource. Maybe not necessarily for this project, but again, just an excellent resource to say the least for studio. However, I'm going to dismiss that and take our screenshot, give or take. Do make sure that you hold shift and make sure it's a completely flat shot. You definitely don't want this slightly angled shot. It is going to mess up with that view. So we do make sure that it's, of course, straight every single time. Sweet. Let's take a screenshot and make sure that our measurement is in there somewhere. Sweet. As you know, we can go to back to Rhino, we can type in picture. And actually the best thing to do here first, since I already have a known, is make a 48 by 48 foot square. So 48 feet by 48 feet. And that's kind of nice because now I make my measurement the same, right? So I'll type in picture. We'll find that shot, of course, in our screenshots. Believe we'll need this one and this one. Doesn't really matter which one you do first. In my case, I'll probably start with the measurement. Fake it till I make it. Dang, I almost got close there. But as you can see, we do need to align it in some way. And this is where, don't get me wrong, you could align your shapes to the image, but I wouldn't, right? If anything, when I'm modeling, especially in Rhino, I want to keep that X, Y, and Z direction. Why? Because it makes it a lot easier to draw. As soon as I turn my model 45 degrees, next thing you know, I got to draw everything at 45 degrees, right? And sometimes that's a little bit more difficult, so be very careful. In my case, I would actually suggest to rotate the image to the square, not the other way around. So for instance, that's looking pretty close. We can ballpark it. Let's face it, there's kind of a fuzziness to that pixelated line. I usually pick this like strong heat point, if you will. Does that make sense? Right? Just to be a little bit more accurate when we zoom out. First thing I want to do is rotate it. So rotate, I'm going to select my base point, which is that line. I'm going to select the other side of my line, kind of fake the midpoint if I can, and basically make that at least straight. The next thing I can do is scale it, select my base point, my reference point, which again, I'd kind of select that hot spot, if you will, and stretch it to 48 feet. Now our image is to true scale. However, let's face it, I don't really need the rest of this, but I do need to align my tool first. So I'll type in picture again. We'll get that topography. Fake it till we make it. Ooh, I like to guess. Dang, I feel like I went too big on that one. Anyway, we need some transparency. Obviously, we want to be able to see it a little bit better. So we'll take that piece, materialize it, and give it some transparency. Sweet. So ballpark it, right? I mean, we want to get as close as possible, right? The best way I find to do this, especially with the contours map, is this actually denotates the middle of our road, not necessarily the edge or the other edge, but also on Google Maps, there's no way of like really telling where the middle is, if you will. So again, actually one of the best things you could do is just actually line up the lot lines. So somewhat like that. I actually nailed it pretty well. And as you can see, we see some visual cues, right, of things that line up, things that don't line up, and it looks like overall my image is actually fairly close. Now, for the sake of the tutorial, I'm not going to spend too much time on it, but this is, of course, where you definitely want to lock in and get those two pieces figured out. Now, let's assume that they are figured out, they're perfectly aligned. It actually makes a lot of sense with the contours, right? You know, pretty relatively flat road. And then, of course, steep, you know, goes down that hill. If you've ever walked around there, you know exactly what I'm talking about. Is there's kind of just like a drop off, right? I mean, it definitely sinks into this park quite a bit. So it's matching reality, and that's always a good sign. So from here, let's face it, I always make a copy, guys, because I don't know, I might mess up, or my studio professor might go, choose a different spot. In fact, I may want to do that myself. Since this is already scale, doesn't mean I have to keep this square here. In fact, I may realize for today's tutorial that's kind of a lot to trace, so I'm going to go with something a little easier to trace today. Maybe it's something a little bit more forgiving. There we go. That way I can not spend too much time tracing and things like this. But now it's still to scale. That box is no matter what, where I move it, as long as I don't change the size, it's to scale. So I'll make a copy, COPY, take it off to the side, and we'll trim this guy up. TRIM, I trim everything. So now we got this wonderful little spot that I didn't have to go to Photoshop just to put layers together. I can do that all in one program. And you know it, we got to trace it now. So I'm just going to make a new layer, call it Trace Topo, since honestly this file is getting a lot of layers on it. Trace Topos. Doesn't really matter what you name it, as long as you can find it. And we've already got a lot of green going on, so let's go with blue. Double click, and yes, this is where I would bust out the Wacom. But specifically, especially in this model, and especially since I'm going to show you a couple of methods of how to make a surface, I do something quite particular. In fact, you'll notice I always kind of draw outside because I can always trim these lines. I can never just make more, and you know, it's a little cumbersome to like add on to a topography line. So very often I'll do something like this. I actually trace it outside and go into the project. You'll also notice that I also do the same thing on the exit, right? I kind of leave a lot of extra, right, just in case I need it. That has just come through practice over time. You'll also notice another thing as I choose the same direction of drawing, right? I don't go this way and then up and then down and then, oh, and then down again. You know what I mean? Like, try to be consistent with the way that you're drawing something, because that actually does matter. These lines actually do have a little bit of code that go, this is the start point, this is the end point. And sometimes when we're putting things together, it takes the start points and it goes, oh, you mean this is it? And it makes a weird surface because it just took the start points. You see what I'm saying? You'll see what I mean when we start lofting. But in my case, you'll notice I start at the top and basically essentially just trace this. Now, you'll notice we do have to fake a little bit of information. After all, it is a little bit pixelated. So we do have to fake it till we make it a little bit, and basically make some assumptions, some educated guesses, as they say. And let's face it, I'm not gonna trace every line for tutorial today, but we can basically just imagine that I did. Now, of course, we can get pretty detailed when it comes to some people prefer curvilinear elements. It does start to look a little bit more topography-like. Some firms, they quite literally do only polygonal, right? So very strict and almost looks like a... Are you guys familiar with the Pokemon Polygon? That guy who looks like, you know, almost like a polygon shape made out of mesh. Anyway, maybe a bad reference for today. But I would say keep it consistent. If you use curvilinear, stay with curvilinear. If you use polygonal, stay with polygonal. But for the sake of tutorial, let's get a couple lines in there. Again, I'm faking it till I make it. Please actually be as accurate as possible, especially in a studio situation. And we'll get one more layer in there. That one's looking good. Sweet. But pretty visually interesting. And if we take a look back at that map, and where'd it go? There we go. We can definitely tell that it actually starts at a high point up here, and we've probably all seen San Pedro Park. I mean, it's like a gigantic hill, essentially, this entire road. One of the longest roads actually in San Antonio, along with Blanco and Nacogdoches. Anyway, they go all the way to Blanco, Texas. They go all the way to Nacogdoches, Texas, but I've never seen a San Pedro, Texas. So I've always actually been curious, why such a long road, and why even call it San Pedro? Obviously St. Peter. Anyway, not to make it a history lesson, but we can get that information and clearly easily see that it's going down, right? So again, you definitely want to verify these things, especially in a studio situation. Now, for the sake of being consistent, again, after everything, I just make a copy. Because let's face it, I hate doing the same things over and over again, even though arguably that is exactly what I'm doing in this class. But, you know, just in case I need it, just in case I don't, I have another copy, right? And some of you guys are probably finding out the hard way very quickly that, oh crap, you know, I should have made a copy. I do have to do this again, but arguably you do usually do it 2 times faster, and let's face it, even 4 times better than the first one. However, if you watched Team A, you know that I'll do the cardboard method first. So I'm going to do a couple. We'll do a cardboard method, maybe a loft method, and I'll show you actually how to go the other way around as well. So we're getting pretty detailed for exercise 5 today. In my case, cardboard method, I do need to essentially fix the rest. So I'm going to do a poly line. And just like I did with the cardboard, I need to basically make little layers. So in my case, I need to keep track of my layers. Sweet. I'll take that piece and that piece, right, and basically trim them up. Now I can do that one at a time, as you can see here. Trim. Doot. Doot. Okay. We'll take that and join it and basically make a solid layer. As you can imagine, yes, I need to do that with essentially each layer. So polyline. And as you can see for this cardboard method, I don't really need the excess, but again for the loft I do. So we'll trim that guy up. And really if you start keeping track of stuff, you can kind of do this all in one step. I don't want to confuse anybody today. This one also doesn't matter which direction I'm going, so I'm kind of going back and forth. Ooh, I can mistrack my lines though, so I may want to actually trim them as I go. In my case, let's just trim them. Cardboard method, we don't need the excess anyway. There we go. This next one and this next one, there it is. Let's join them. Again, just making closed curves, just like we saw, was it yesterday? Yeah. Oh no, day before. So we got a layer, we got a layer, got a layer, got a layer. All right, we got 3. Next one, polyline. Oh, already got that one. Oh, maybe I do. Do I? No. Okay. Polyline, back to the corner. Now see, this is where near is extremely dangerous, right? Because I could pick any point on that line, but I do need an exact closed curve. So again, be very careful with near. Can't tell you how many times I've messed up my draw lines because I was like, man, I had near on, you know. It happens. You know, you learn through mistakes for sure. We'll do a couple layers more. Again, I'm not trying to make this a super long tutorial or anything. Just an accurate one. So I'll take that one. As you can see, I do have to kind of flip through the lines sometimes. Oh, I accidentally got the wrong one. One thing to kind of avoid that, by the way, is to essentially hide them as you go. So like, say I finish one, hide. Finish another one, hide. Because let's face it, one day we got like 1,000 topography lines, right? So you definitely don't want to do these things over and over again. So at least one of the methods I use is just hide the one that's next, right? And it looks like, yep, I got it. Join, hide. That way I know. Polyline. Also keep in mind, I don't know if I actually said this, but if you hit spacebar, it enacts the same command over and over again. So I don't know who needs to hear that, but sometimes it's really nice. Also, there are shortcut keys. So like join, you can just hit the letter J. For move, you can just hit the letter M. So some of these things actually do have shortcuts. And to be fair, you can set them up on your personal computer to do whatever you want. Like if you want to say what and have it make a line, you could. I don't recommend it, and please don't do it to the school computers, but it is actually a pretty customizable software. So hide, and why not? Let's get all the lines today. Go big or go home. All right. As you can see though, it does take a little bit of time, and if I wasn't talking so much, it would probably go a little faster. Intersection, boop, intersection, enter. Sorry, I do forget to like call out what I'm typing and clicking on sometimes. So, and then we could just type in show and they all come back. So again, I may need a flat version. I don't know. My studio professor might need a site model or something. So again, I'm gonna make a copy. Or I might have messed up too. I mean, shoot, and just like not even known it or recognized it. I am screen recording, right? Yes. Thank goodness. I didn't have Gavin to check in on me. But we are recording. What do they say? We are live. Anyway. Alright, cardboard method, same thing. We gotta basically lift each layer by 1. So I'll take this piece, the one that I want to work with. I'll go to another viewport and isolate it. There it is. And essentially take one layer at a time. What I like to do is actually just go down or go up. It depends honestly on the topography surface, but I'll hit M, 12 inches, enter. I'll take both, spacebar, 12 inches. You can also hit the number 1 because it's in feet already. So we can even get easier on this. We'll take each thing, spacebar, 1, enter, and so on and so forth. And essentially just get each line and bring them down 1. So not too shabby there. However, don't lose track of your lines like I'm about to. Ah! Oh, what have I done? There we go. Alright, that one looks up. I don't know. There we go. Here, let's isolate that, because as you can see, it's going all crazy. So when in doubt, always zoom select. Best tool in the world. Alright, we're good. I'll take that one, all 4 of those. But should look familiar, right, if you were paying attention on Monday. Of course, the cardboard method again. Tried and true, can't go wrong. Because let's face it, they rely on the architect a lot for accuracy. In fact, we get made fun of it all the time by contractors, like, oh, they don't know what they're doing, they don't understand reality, they just draw something. And that's not necessarily true, especially at San Antonio College, where we throw you out into the real world and go measure it, right? Definitely realist in that way. But looking pretty good, and now we have like a wireframe, right? So you can kind of see it, you know, there's kind of a 1980s video game style going on. But again, I may want that, so I'm gonna make a copy. I just never know what my studio professor is gonna do next, so I want to be prepared, right? Extrude. And of course 12 inches. And that can go bottom or go up or down. Honestly, it makes the exact same model. But yep, there's the cardboard method, and pretty much all we need for this exercise. So as you can see, it shouldn't take too long, but I do want to show you how to bring it to the laser cutter again. But let's go over some other things, right? So there is a lofting method. So essentially it's the exact same thing. In fact, I might cheat a little and just take this one because it's already set up. But we'd essentially do the same thing to this one, but we'd move it one at a time. So for instance, just to kind of show you what I mean, we'll isolate it in that view. Where you at? There we are. And we'll take basically one line at a time, the same thing. It's kind of like the cardboard method, but you know, essentially a little, it's more like if I was rendering it and I wanted it to actually look like the ground, I wanted it to have the bumps and like the, you know, not look like cardboard, for instance. Like right now, I mean, that totally doesn't look like it does outside. There's not like stair steps outside, and it's a little bit unrealistic. Now, often in architecture, we're representative of nature. We're representative of earth, buildings, concrete. What do we use for concrete? Basswood or chipboard. What do we use for earth? Cardboard. We're representative, right? But sometimes that's not enough, especially if you want to do a digital rendering and you're trying to go for realism, right? And you kind of want the bumps, and let's face it, this isn't the greatest example of a topography, but sometimes they're quite unique, right? Like you saw on the example page. Maybe it's an entire mountain sometimes, those kinds of things. But in my case, I can also loft something. So for instance, let's fake it till I make it for today, 12 inches. Again, essentially I have to do the exact same thing, take each line. In my case, I'm going to show it both ways and go up 12 inches now instead of down. So again, just kind of proving that there isn't a right or wrong answer to this. As you can see, it does take a little bit of time. However, some people have gotten really smart. They know how to script stuff. And, you know, one day you'll get there in Grasshopper too. But I don't want to absolutely confuse you guys, but as you can see, you can kind of see the same thing, right? There's kind of this wireframe surface. We just didn't complete the rest of it. But we'll take each piece. And also, it does matter the order that you clicked it, by the way. So you'll notice that I kind of went in order. If I go like this, it's going to assume that I want this surface to go like that. So be careful the way that we select things. Also, those things matter when we select them all at once too. That actually randomly generates what it selected, so be careful. This is something that if you're doing the loft method, you want to hold shift and actually add those one at a time, which can be actually painful if there's 1,000 topography layers, but sometimes you just got to do what you got to do. So we're going to type in loft, L-O-F-T, and as you can see, it's going to kind of try to make a surface for us, right? It's gonna do its best guess, and for the most part, it's actually looking quite topography-like. But you'll notice some things are missing, like this top piece up here, and this bottom piece over here. So I may need to actually add some more information. So for instance, I'll take another line and basically put it out here. And maybe since my contours map, well, I may need to actually have to go back and go, ooh, you know, I need a little bit more information, right? Maybe I actually draw this one as well, right? So again, the lofting method, I'm not requiring it, and it's not, you don't really need the lofting method for necessarily this exercise, but you may need it in studio, right? So I didn't want to rob you of that technique. But in our case, let's see if we can get it to work. I'm not going to lie to you, it's kind of a hit and miss, and very often you do need a lot more information. So in my case, let's go big. And I need the top one too. Oh, and I definitely shouldn't draw it in perspective. That would be a faux pas for sure. Let's do it out here. In my case, kind of faking it, right? But in y'all's case, I would just, you know, trace the topography. Right? Some of it you may realize like, ah man, that didn't even go far enough. I may need to move some things out. Those kinds of things. But let's try it again. And that one's definitely too short. Hold on. Boop. Actually, a few of these are too short. We can hit F10. I don't know if I've actually shown this, but function key, F10, you can actually get all the points of an object and stretch them out. I don't know who needs to hear that, but you never know. You run into these situations all the time. But it's looking a little bit bigger. Let's try it again. Loft. Ooh, definitely want to select that one first, then that one, then that one. Loft it. All right. Do we cover the whole square? Man, so close. But for the sake of tutorial, obviously we'll leave it there. To fix it, obviously I would just, well, what stinks, during loft you can't actually change anything. It's super annoying. You can if you loft in Grasshopper. There is a loft command in Grasshopper, of course. And you could do these things in real time. It is quite restraining on the computer itself, I will say. But, you know, I think honestly one day we're going to strap something to our head. We're just going to think these things, and it's going to, like, model it. You know what I mean? And it'll be the best thinkers. It'll be the best creative poetry writers that eventually start sculpting our world. So I'm honestly looking kind of forward to it. We can stop building boxes and maybe make grand architecture again. But that's just me. Anyway, kind of want to show you what it does if we just select everything. Sometimes it can figure it out. Often, it doesn't. And as you can see, it's kind of going everywhere on that one. It kind of figured it out. It's not too shabby. Something seems off about that one, but I think it's just the points. But we finally got that whole box. So in my case, there's a couple of options, and you might want to actually go through them, but look at them actually in like a three-dimensional view, because it is kind of weird. There's usually by default it's normal. There's a type method, which it's trying to like, it's almost like if you can imagine somebody putting a cloth on these items and they're like either pulling it or just letting it be loose, or we can actually control the number of basically subdivisions, which is actually what control points are called here. We can close the loft, which I don't recommend. It's trying to basically go, hey, did you want to close it? Again, maybe we don't need that for topography, but again, if I was making a roof for the design of my architecture, well, this might be very useful, right? I could loft a surface, especially something that last time I think we talked even about loft was maybe exercise 2, and that was very briefly. So in my case, I maybe select loose and definitely don't close the loft, right? Otherwise it won't be a single surface. In my case, I could rebuild it and say, oh man, I want 150 points. I want this to be really, really, really close to the bump. And as you can see, I can get hundreds of lines, 150 lines in a matter of seconds. But now that we have that piece, we got to trim it. We got to slice it up. You'll notice, you know, if I try to use wire cut, I can't wire cut a surface. We all knew that from exercise 2. So we'll have to offset that surface and cut it up, right? In my case, I want to be as slightly as smaller as possible. I don't want my object to accidentally go into my object again because I want to wire cut it. But let's see what it looks like cut first. So offset. Oh, sorry, offset surface. There's a lot of different offsets. Offset surface. We'll go with 2 inches, real thin. All right, just enough to call it a solid object. And we'll now wire cut it with this box. So put it towards the top, wire cut, object, enter, goes straight through the object, and voila. We have a wonderful, nice little surface that arguably looks a little bit more realistic, no? Right? Not too shabby. You could impress your studio professors. They're like, how did you make the surface of the Earth? Right? Oh, I learned in computer graphics. But we can check it out in rendered mode, and it actually does start to give, I mean, don't get me wrong, you can't see it too well in a rendered mode, but definitely hyper realistic compared to what we actually see in reality. Again, not required of this assignment, but again, may come up in studio. Let's continue and finish off with showing how to make this. So eventually, we're actually going to put our columns of our abstract model, obviously inside these. But say I needed to print this out right away, and I needed to make it for a studio. Maybe I'm making just a study model. I'm not getting too fancy with the spices. Maybe I haven't even figured out my design yet, but I just want a study model. That way I can start actually modeling by hand on it. And that may be very useful instead of spending my time cutting, maybe possibly, let's face it, have you seen some of the topography out there? It is 2 foot by 3 feet, right? And what is that? I know, right? You could have used the cardboard method. Maybe I was seconds too late. However, keep in mind, sometimes studio professors, they don't want you to use laser cutters too. So it is preferred that you ask, hey, is it okay if I construct this with a laser cutter? Some of the older guys will say, no, we don't want to see that. Whereas some will say, no, we want to see that for the final model. I don't want to see it for the study. Some people are particularly picky, but at least now you know to ask. But yes, it does simplify the process, right? The good news is, this won't be the last time you make a site model, but let's face it, eventually they get really big, and for like the studio competition, you got a lot to work with, right? So in any way that we can make it easier, we might as well. What's also nice about this, guys, so let's say there's actually this wonderful thing. I won't necessarily like go through the whole process, but another website that's really great is called Terrain, and I can't remember if there's two. Terrain 2 as in the number 2, and then STL for a stereolithographic file. If we hit enter, there's this wonderful website called Terrain 2 STL, but then it's also called JT Hatch. I don't know, maybe that's his name, JT. But if you click on this, you can essentially go to anywhere on Earth and basically produce a model, right? That's kind of nice. Now, it's not a topography model, but it's more like that lofting surface model, but it's a bunch of triangles. So like for instance, maybe I download a model. Let's face it, hydrology and contours map, that only works for San Antonio. And we don't do every project in San Antonio. Maybe we have one in Dallas and they don't have a contours and hydrology map. So sometimes I actually have to go out, and especially when I have a house in the middle of nowhere, Texas, I can't go out there to go measure the topography lines. I gotta find some maps. I gotta be resourceful. I gotta be, find that information. So I'll often create a digital map, and then I can actually use contours to create that topography map, right? So actually I can go the other way around. As you can see, if I type in contours and spell contours correctly, there's a couple things we can do here. So I can take this map. In my case, it's going to ask for a base point. So I'm going to basically tell it the bottom, right? The bottom of the top of that surface. And basically say, well, make sure you go in the right direction. I want you to go up in the Z direction. Now, I do want you to do it every foot, right? Because I want to get the topography, right? Which we know is either 1 foot or sometimes 5 feet, depending on the map that we're making. So I'm going to select 1 foot, enter, and voila. I got the topography lines back, but now from the surface itself. So again, we can kind of go back and forth. And I know I'm getting really into the sauce of topography, but again, obviously, hopefully helpful with Studio. Last but not least, let's talk about how to get it for the laser cutter. We talked a little bit about this with Team A, but just kind of a recap, I would definitely use a cardboard method for the laser cutter. So I'm going to go ahead and make a copy because, let's face it, I'm going to take this guy apart. And did I already make it? Oh, that was Team A. That's right. Well, let's hide this real quick. These images are freaking out during my screen recording. I don't know about you, but I'm not epileptic, but I feel like it sometimes. Like when I get like weird flashy images, I'm like, whoa. nauseating even. But in our case, let's turn it into a laser cut model. So in my case, I just essentially want to take each layer at a time. And I don't necessarily need the curves on this one. So I did make a copy, so I can take actually my filter tool, disable, and I just want my poly surfaces, or I do have actually both here. I could take my curves on this one and just cut them, or I could take my 3D model and cut them. I don't necessarily need both. So in my case, I'm just going to take poly surfaces, sweet, and go ahead and turn that back off, because let's face it, very annoying sometimes. But I could either just laser cut that or take these out one at a time. Either one is perfectly correct. In my case, I do want to get these as close as possible, right, to maybe save some space on my laser cutter or my particular sheet. But we just need to pull them out one at a time. And actually, it wouldn't be a bad idea. We could go up there and laser cut today. I mean, it's only 10:11. Don't worry, I probably won't have time, so we'll leave that for tomorrow. But it's looking pretty big. We do have to do our wonderful scaling method, and since this drawing is actually, oh, where did Miro go? Where'd you go? This model is actually at a 1/4 scale, and I may have missed that part, so I do apologize. It is at 1/4 scale, so this model. And eventually we're going to 3D print it too. But I want you to learn the laser cutter, right? So last year, the reason we couldn't use the laser cutter is somebody destroyed it, right, during the capstone competition, right? Was that y'all's year? I think so. So we couldn't use a laser cutter. So the way that I'm switching it up this year is let's make a topography model just for the sake of exercise 4, right? However, the end of exercise 4, we're going to actually make a digital model and put it inside this topography. Right, so eventually we might have to make 2 topography models, if you will, but it should be relatively inexpensive, right, to say the very least. But we'll go ahead and make it at a 1/4 scale because, well, just to give you a hint, we're going to make it at 1/4 scale. And I need to do a little bit of math. So I'm going to get my calculator. I could probably do this math internally, but just to kind of show you what I'm doing. We'll basically do 12, so 12 inches by 24, that's our laser cutter. So 12 times 4, 48. Right? In my case, 48 feet. Right? Oh, that can't be right. Actually, I think we make it at a 1/8 scale, my bad. So we'll times it by 8, which is 96. Rectangle. There we go. So 96 feet. There we go. And what's 96 times 2? Gosh. Is it 184? Let's find out. My math is not usually good before 10 o'clock in the morning. 24 times 8. Yeah, 192. I was close. 192 feet. So this actually represents our 1/8 scale, sorry. 1/8 scale is what we're making this model as. And we basically just have to fit these pieces, right? So for the most part, since I know that it's exactly 6 inches by 6 inches, being 48 feet by 48 feet at 1/8 scale, I can't actually put these right into the corner. And my last piece, dang it, can't fit it, right? I mean, maybe we can. Let's see. Oh man, right on the line. Nailed it. Ooh, I don't know, there's a little bit of overlap there, isn't there? Shouldn't be. But again, not detrimental. But now we can make 2D. Awesome. Apply. Go back to our origin point. And there's the part that we need to laser cut. So we'll definitely save this off and we'll get started tomorrow, actually probably doing some laser cut. However, I got a lot of separate objects right now, so I'm going to actually put those together. Join. And it's going to automatically join stuff that is touching, right? So it's going to automatically put those together. And in my case, I can actually use the same line to cut this, right? Which is why I did that make 2D after I kind of moved it around, because that same line is cutting technically both sides. And I don't actually want 2 lines. In fact, it could lead to burning, like doing 6,000 lines in one spot. Definitely causes a fire, as we learned. But in our case, actually, I want to minimize my time. I want to minimize the amount of burning that I give to this piece of paper. So, well, one line is definitely better than 8,000. That's clearly going to burn our material. But in my case, it's already blue, so it's ready to be cut. But I do want to make a cut layer and a score layer. It's just good practice. Of course, that score layer is always perfectly red, so make sure it's red. And of course, the cut is always perfectly blue, not an off blue, perfectly blue. As I mentioned in Team A's video, it literally only cuts blue and it literally only cuts red. If it's slightly off, it doesn't work, right? It'll basically show that there's no lines there. However, right now my border is also blue, bless you. So I'd want to switch that to a different piece as well. So that's looking pretty good. Essentially from here, I'll basically save it as a Rhino file and we'll take it to the laser cutter. So nothing too shabby here, but just to give you a hint of where we're going with this, essentially we're going to use our topography model. We're going to 3D print our put together building in part 2 and 3, and we're going to put that inside that topography. Right? That way, potentially a professor could even remove it and go, oh wow, right? You know, you're taking those things apart. Honestly, for the sake of computer graphics and tutorials, we're just going to do it because we can, right? That way I can show you the laser cutter a little bit, and I can show you how to 3D print. So, other than that, this is essentially part 1, right? And part 1 will probably push a little bit. We don't have a whole lot of students, but we should be okay in the amount of time that we have with the laser cutter. There is no class in there this semester, so we should have free range in terms of using the laser cutter. But I'll go ahead and make another video probably tomorrow for the laser cutter, right? That way it'll help out Team A and help out Team B. So, other than that, probably a nice recap from Monday's episode. Any questions about topography or the assignment itself? Sound pretty good? All right, we'll end it there for today.